Hi everyone, my name is Danish Kumar, and today we will be talking about how solar can reduce the energy cost of your facility. And we will have a demo of a tool to check potential of solar at your facility. So we know that small drinking water systems face many challenges, from aging infrastructure and changing public health standards to population shifts and higher customer expectations. Energy is often one of the biggest expenses, and pumping alone accounts for the majority of electricity used, and energy cost can take up to 25 to 40% of a system's entire operating budget. On top of that, rising electricity rates and demand charges can stretch already tight town budgets. And reducing energy costs can have a ripple effect across your entire operation. For example, every dollar saved on electricity is a dollar that can go back into infrastructure upgrades, source water protection, improved treatment technologies, or community outreach. This is where on-site solar really shines. It helps cut your energy bills, stabilizes your long-term cost, and shields you from unpredictable utility rates and demand charges. And the good news is there are several options to make solar affordable for you. There are some tax credits available in certain local governments and states, and even low cost power purchase agreements can make it possible to install solar with little to no upfront cost. Solar projects usually last more than 25 years, showing your community that you are investing in long term affordability, sustainability, and resilience. Now, let's take a look at a free online tool called PVWatts. This tool helps you estimate how much solar energy your site can produce each year. So, this PVWatts tool is developed by National Renewable Energy Lab, and this would be useful for you to assess solar potential at your site. And we will also talk about calculating savings with this with another tool in another video as well. So when you go onto the PVWatts website, you'll have an interface like this, and you can go and type address of your facility. You can also write it your address as well. I have put coordinates of a facility, of a location. Then if you click on this go button, it'll show you a map view of your facility, as you can see here. Then now for the solar potential, if you don't know what the uh, system size could be, like how many kilowatts of system your facility could host, I would prefer using this rooftop size estimator. And if you click on this, it'll take you to the map view around your facility, where you can zoom out a little and map area available with your mouse. So for example, if I zoom out a little and go on my project site, I can see that there is some area available which I can use to install solar as well. So if I just draw like these four corners of your facility's available area and click save, we can see that it will automatically give you information about solar system size, just some information about the design parameters of the solars. There are some advanced parameters as well. So if you are well versed with solar design, you can play around with that as well. But I would suggest you to keep these as they are. And then for the next step, you will click on this arrow and it will show you how much energy your solar will produce in a year. So as we can see that it can produce like the 94 kilowatt system can produce almost 130,000 kilowatts hour per year. And we can also see its monthly background as well. But you can also download these files for like monthly or at even hourly production data as well for your future reference in Excel format. PVWatts is a great first step to explore how solar can work for your facility. I encourage you to try it out for your site, save the results, and start thinking about solar and how it could fit into your budget and long term. So this brings us to the end of this tutorial. I have added my contact information. If you have any questions or need further assistance, you can reach out to me via this email. We hope this session helped you understand the key steps to assess solar feasibility at your own facility. Thank you. See you next time.